Okay, so this video is meant to go through some mathematical examples of transformers. So the first example says a step-up transformer has a primary coil of 200 turns, so that are the number of turns in my primary, and a secondary coil has 3,000 turns, so that's the number of turns in my secondary coil. It says the primary coil is supplied with an input voltage of 90, so that's my primary voltage. What is the voltage induced in the secondary coil? So I'm trying to find Vs. And if the current in the primary is 2 amps, so that's my current in my primary, what is the power of this transformer? So let me kind of break down the things that I know. I know that the number of turns in my primary is 200. I know that the number of turns in my secondary is 3,000. I know that the voltage of my primary is 90 volts, and I know that the current in my primary is 2 amps. And I'm looking to figure out what the voltage of my secondary is and what the power of this transformer is. So we know that the mathematical relationship for transformers is that the voltage of the secondary divided by the voltage of the primary is equal to the number of turns in the secondary divided by the number of turns in the primary. So it's just a simple ratio, and I can plug in what I know. I'm looking for Vs. My Vp is 90, and my number of turns in my secondary is 3,000, and the number of turns in my primary is 200, and so you would just get out your handy dandy calculator, figure out what the voltage of the secondary is, and that comes out to 1,350 volts. And that makes sense because if I have more turns in my secondary coil, that means I'm going to have a larger voltage. So the second part of the question wants to know what is the power of this transformer, and we know the current in the primary coil is 2 amps, so make sure that's labeled there. That means my power is just going to be IV. So whatever the power of the current of my primary, which is 2, times the voltage of my primary, which is 90, and that is 180 watts. Okay, so for this next problem, I'm having a picture. So this is a picture of the specs for my USB charger. So it's your classic USB charger, and you can look here. I'm going to zoom in a little bit, some of the numerical values. Notice it has an input and an output system. So input, I've got 100 to 240 volts. So this means that I can plug it in here or I can plug it in Europe. Here it would just automatically detect that I've only got 120 volts going in. If I have it in Europe, it would detect that I have 240 volts going in. So it just internally knows. 50 to 60 hertz is just the rate at which the alternating current is being delivered. Here in the US, we have 60 hertz. In some other parts of the world, I think like in Asian countries, it's only a 50 hertz value. And we're told that in the input, it's got 0.35 amps. And for my output, it's going to give me a direct voltage, so a DC. I don't have an alternating current, so it's just going to be a direct current of 5 volts. And at 2.1 amps. So in my questions here, it says, what is the input voltage? Well, here in the US, we're just going to assume it's got 100 volts. Realistically, it can vary between 100 to 120 volts, but we'll just take the lower voltage here in the US. What is the output voltage? It says right here that is going to be 5 volts. Is this a step up or a step down transformer? It is a step down transformer. It takes it from 100 volts to 5 volts. What is the ratio of the number of turns in the primary to the number of turns in the secondary? So remember, this is my primary voltage and this is my secondary voltage. So remember, my relationship is that the voltage of my secondary divided by the voltage of my primary is going to be the number of turns in my secondary divided by the number of turns in my primary. So this would be and it goes, I want to know the turns in the primary to the secondary. So I actually want to know the flip of this. I want to know NP over NS. So that is going to be 100 divided by 5. And so it's a 20 to 1 ratio. In terms of what's the input current, that's just looking at the specs, is 0.35 amps. What is the output current? That is going to be 2.1 amps. What is the efficiency of this transformer? So efficiency is looking at how much power I put in. So power in versus power out. So if I think about the power in is going to be my I primary times my V primary. My power out is going to be my I secondary times my V secondary. So I primary, we said was 0.35. V primary, we said is approximately 100. So my power in is approximately 35 watts. And then my power out is my I secondary, so 2.1 times my output voltage of 5. So my power out is 10.5 watts. So if I think about what my efficiency is, then I need to think about, okay, I have 35 watts going in and I only have 10.5 coming out. So efficiency wise, it's like saying I've got 10.5 watts going out versus I only have 10.5 coming out compared to the 35 that I had put in. So we're just going to do a simple division there. So 10.5 divided by your 35, and this means that this is approximately 30% efficient. So not very efficient.